All right, for the next examples we're looking at, they're a little bit different. It says, for each of the following functions, find the area a of x from the graph of f in the interval from a to x, which they're saying is from -1 to x, and find the derivative a prime of x of this area function. So notice how this one differs. It's not saying estimate the area using 2 rectangles or 4 rectangles or anything like that, okay? But I still do want to draw a picture of this function, okay? So what does this function look like? F of x is equal to 4. It's going to be a horizontal line. It's going to look like this. It's going to look something like that. F of x is equal to 4, okay? Now, what do they want here? They want me to find the area between f and the x-axis and between the interval from -1 to x. So here is about where -1 is, and I'm going to say some x over here, okay? Now, I could put x here, I could put x here, could put x over there, could put x here. It doesn't really matter. It's just x needs to be to the right of -1 because of the way that's written. All right, so now what do they want? They want this area from -1 to x and underneath my curve between the x-axis here, okay? So they're looking for us to find this area right here, okay? Now, they do not say to estimate it using rectangles. So how do I do this? Well, if you look at that, that's just a rectangle itself, right? So I know the area of a rectangle is equal to length times the width, right? So I'm going to say the area, a of x, of this thing is going to be the length times the width. Well, what is this length right here? What is this length from x to -1? Isn't that right here, this length, x plus 1? Yeah, think about it for a second. If this was 0, that's x units long, right? And this is 1 unit long. So x plus 1. Another way you can think of that is you can think of it as this. What if I have 5 and, I don't know. Tell you what, let's pick 3 and -2 on the number line, okay? So here is 2, here is 1, here is 0, here is -1, and let's say here is -2, okay? What if I wanted to find the length of this interval right here from -2 to 3? How do you do this? Well, you take the leftmost number, 3, and you subtract the rightmost number, -2, right? And what does that give you, 5? 1, 2, 3, 4, 5. Hey, I did it right. Okay, but anyway, how do you find the length of the interval? Take the rightmost number, subtract the leftmost number. Isn't that basically what we did right here? We took the rightmost number on this number line right here. We took the rightmost number, x, and we subtracted the leftmost number, which was -1. Well, doesn't that give me x plus 1? So this width, or this length of my rectangle is x plus 1. So whenever I put in the length, I'm going to put in x plus 1 times the width. What is my width of this rectangle? What is the width right here? Well, what is the width from here to here? It's got to be what? 4, right? So times 4. Now let's calculate that. As a of x is equal to 4x plus 1. Now what do they tell me to do? Find the area a of x. Here's the area a of x. And then they say find the what? Derivative of a prime of x. So a prime of x is equal to what if I take the derivative of this? 4. There we go. Let's look at part B. Part B. Part B has the same directions as this one, okay? So what I'm going to do for part B is I'm going to draw a picture first of all, then I'm going to go from there. Okay, for part B we have f of x is equal to 2x plus 2. So let's draw a picture of this, okay? So let's see. What do we have? So let's draw a picture of 2x plus 2. 2x plus 2 is just a linear function with a y-intercept at 2 and a slope of 2, right? So I have something like this, okay? Now what do I want? I want the area under this curve between, they told me, -1 and x, right? So let's find where -1 is here. Wouldn't -1 be right here? Think about it. What is a 0 in this function? 2x plus 2 is equal to 0. So 2x is equal to -2, or x is equal to -1. So at -1, my function hits the x-axis there. And let's go out to some x. So we're going from -1 to x, right? And this is f of x is equal to 2x plus 2. There we go. I drew my picture, okay? Now, what do they want? They want the area right here between -1 and x, underneath that graph of that line and between the x-axis. So what shape do I have right here? That's just a triangle, right? We know the area of a triangle is 1/2 base times height. So area is going to be what? Or they want me to find a of x, they say, is equal to 1/2 times base times height. What is my base here? What is this base length right here? From here to here. Well, how do you do this? You take the rightmost point, x, and you subtract the leftmost one. X minus -1, that's what? X plus 1. So what is my base length here? X plus 1. Times my height. What is my height going to be? Well, my height of my rectangle is from here to here, right? Well, what is that height? That's whatever this value of y is right there, right? So couldn't we say the height right here is my function f right here, evaluated at x? So my height here is this function evaluated at x. And what happens if I evaluate that function at x? I get 2x plus 2. So my height from here to here is 2x plus 2. So my height, 2x plus 2. All right, let's multiply this all out. A of x is equal to x plus 1 times, let me get better at that. Let me just speed up here. X squared plus 2x plus 1. Whoa, how'd you do that in your head? Okay. Not that I'm a genius. What I do, I just said, okay, factor 2 out of this. And the 2 multiplies by 1/2 just gives you 1, right? So you have x plus 1 times x plus 1. Square x plus 1. And you can do that in your head. And you get that, okay? How about they want me to find a prime of x. A prime of x is, just take the derivative of this, 2x plus 2. Now I want you to notice something. This example and the last example. After we found the area function, we found its derivative. And what did the derivative come out to be in both cases? It came out to be that curve above, right? Okay, we'll talk about that more later, okay? But keep in mind, that area came out to be the curve above. Before I can do part C, we need to go back to 3rd grade for a minute. Let's see, let's go back to 3rd grade, because that's probably the last time we saw this stuff. In fact, I had a student that was in my calculus class one semester tutoring a bunch of 4th graders, and then he said, that's actually helping me with the calculus at the end of the semester, because I have to go over these formulas I haven't seen in years, and it really helps me prepare for calculus. All right, let's see what we're talking about here. Oh, I can't draw. What if I have this shape right here, okay? You learned way back in the day that that is a trapezoid, right? And the way they probably defined it was they said, okay, it's a polygon, so a closed figure made up of lines, basically, okay? And it has opposite sides, or one set of opposite sides that are parallel to each other. So this side is parallel to that side, but this side is not parallel at all to that side, okay? And what they said was, they said that this was the height of this trapezoid. So the height is going to be this side right here that's not parallel to the other side, okay? And they called this a base, and they called this a base, and they said that's base 1 and base 2, okay? So in other words, your bases are going to be the two opposite sides that are parallel to each other. But your area of trapezoid was 1/2 times open parenthesis base 1 plus base 2 times height, okay? Now, what if I take this figure and I turn it sideways like this? What if I take this whole figure and rotate it like that, okay? So if I take this whole figure and rotate it 90 degrees counterclockwise like that, this height becomes a bottom, right? What happens with this base? It comes up here. So that's base 2. What happens to this base? It goes over on the side here. So that's base 1, right? And then this is the diagonal, right? Now, if I rotate this thing, now I realize that I can't draw them exactly the same size and shape, but if I take this thing and actually rotate it and make it the same size and shape, isn't the area going to be exactly the same? So it's going to be the same formula. It's just now you have your height at the bottom and your bases on the sides. But it still holds what we said earlier. The two bases are the two opposite sides that are parallel to each other, and your height is that straight side otherwise, okay? All right, so let's keep that in mind, and we're going to work part C. Part C. Part C, if I can find my papers here. Okay, part C says we have f of x is equal to 2x plus 2, and we want to find the area between this curve and the x-axis and over the interval from -1 to x. Let's draw a picture of this thing, okay? Wait, did I just copy down? Yeah, I just copied down B. Part C is f of x is equal to 3x plus 4. Change this to 3x plus 4. Maybe I'm going crazy because lack of human contact now. Let's see. -1 is somewhere over here, right? And my x, I can say, is somewhere over here, okay? Let's draw a picture of this. Well, let me see. Where is this function at -1, okay? If I substitute in -1 here, what do I get out? A 1. So -1, I'm at 1 right here, okay? Where does this function go through the y-axis? It goes through at 4, right? mx plus b. So I'm going to say that's 4. This is not drawing the scale at all. Actually, I'll tell you what, I don't have enough room to do that, but you could do that on your own, the paper. I'm just going to draw this thing looking like this, so I don't run out of room here on my board. All right, what do I want? I want the area between -1 and x, according to this, and between this curve and the x-axis here, okay? So I'm looking at finding the area of this stuff, right? Now, what kind of shape does this figure make? Makes a trapezoid, right? Now, this side is parallel to this side, right? So wouldn't that be like a base 1 and a base 2 here? So then this part will be my height, right? All right, so let's find this height. What is this height right here? How many times have we had this? Twice already, right? Wasn't it x minus -1 or x plus 1? What is the length of this base 1? Well, if this is the point negative 1, 1, aren't I going from 0, a y value of 0 to a y value of 1? So that would be 1 unit. How about this base 2? What is that going to be? That's going to be my function f at x, right? Well, what is f at x? 3x plus 4. All right, so my area function, a of x, is going to equal to, according to my area of a trapezoid, it's 1/2 times base 1 plus base 2 close parentheses times height, right? So a of x is equal to 1/2 times base 1 is what? 1 plus base 2 is 3x plus 4 times my height, which we came up with what? X plus 1. Well, let's simplify. So that's 1/2 times 3x plus 5 times x plus 1, right? So that's 1/2 times 3x squared plus 3x plus 5x plus 5. And that'll give me 3/2 x squared. That gives me 8x, right? Half of 8x is 4x plus 5/2, and that's my area. Now they want me to find a prime of x, right? They want me to find the derivative of a prime of x. What would that be if I take the derivative of this? 3x plus 4? Is that the same thing as my curve right here? This was f of x is equal to 3x plus 4. Sure is. So let's make an observation. So for everything we did, we found our area function. Whenever we took the derivative, a prime of x, whenever we took the derivative, what did we come up with? We came up with the function f of x, right? So whenever we start out with the area function, like we did here, and we took the derivative of it, we came up with the curve itself, right? There's something called an antiderivative. What does that mean? That sounds horrible, huh? Sounds almost like the Antichrist or something, okay? But what is an antiderivative? It's basically going backwards what we've been doing all semester, okay? So what if I start out with this and I go backwards and take what we call antiderivative? What if I start out with this curve and I take the antiderivative of it? What do I get? I get the what? Area. So if I start out with the area function, take the derivative, I get the curve above it. If I start out with the curve above it and I take the antiderivative, I get the what? Area function. Those of y'all taking on, going on to take Calc 2, very, very important. With that, you're going to do a lot of that.